Ludik, and as my colleague introduced himself, Johan Nel. Okay, so this is an overview of what I want to talk about today. It's basically our history, where, when, and why did IXUS originate, give you a bit of an idea about our clients in the world, our international client base. Want to show you what the IXUS suite is all about. Entails a few components that we will cover in both the slides and also in the interactive demo. But at the core of our philosophy, of the IXUS philosophy, we are focused on doing things simple, efficient, and accurately. This is what we want to, this is what we designed, this is what we offer you guys. I want to go into our antenna modeling process a bit. What is the general strategy that we follow, and also how our efforts and expertise that we've given into 5G antenna modeling. This is a part that I feel we are very strong in, and that I think we compete quite well in this market. But I'll get into that in more detail a bit later. And then for the current user base, I want to show you guys a bit what's coming up now in IXUS 2021.1. But it'll be useful also for people that have no idea what IXUS is, or no experience with it, to get you up to speed with what are the latest developments that we've added to our software. And this also includes now spatial averaging, which is definitely something that is becoming more and more important in this compliance industry. Okay, so history of IXUS, who are we? We are a team within a bigger company called Alphawave Mobile Network Products. We are based in Stellenbosch in the Winelands here in the Western Cape region, close to Cape Town, in South Africa. And we've been in the business of EMF and RF safety assessment and products since about 2005. We effectively started out as a mobile network services company that had to offer this EMF and RF safety assessments for big operators here in South Africa and Africa. And very soon realized at that particular time, we couldn't find tools that really met our needs. And that prompted us to develop our own one. So that was when IXUS was born. And the first release came out in about 2009. So it's fairly, it's fairly well established, and it's been used. It was developed with a use case in mind. It wasn't, we actually were users of the software for quite some time. This company since branched off a bit. It's not entirely part of our group anymore, but we still support them. This is a very useful thing if you've got a user sitting in very close vicinity to the product that you are actually developing. But since 2009, our user base have exploded internationally, and we also cater for different markets in different countries. I'll show you guys now. Apart from software and services, we also in Alphawave Mobile Network Products have personal RF monitoring equipment like FieldSense, and I believe FieldSense is also making its mark in the international market quite well. This is also a product that we offer, and we also work very closely with this team. As I mentioned, IXUS was designed out of necessity, and we wanted an efficient, easy to use, and accurate solution to this very niche problem of RF safety analysis. Our user base started off here in South Africa and very soon moved into Africa. But within a very short period, other countries realized that we have a very nice solution a very nice tool set to aid them in this compliance assessments. And Australia essentially came on board, and we cater for a very large part of the operators and consulting firms in Australia, as well as New Zealand. And then in the East, we offer services to Singapore, India, Malaysia. Soon, we've also branched out into Europe. We supply IXUS to the operator there, Bouygues Telecom, and also a few others in the UK. We have clients in Canada, we also have distributors in Canada, and we are, since about for the last 2 years or so, we've had collaborations with folk in the US, with teams in the US. We've been involved in quite a few exciting projects, and as I will show you later on, this is a very hard driving factor for us to really start catering for this market more efficiently. And some of the features that we've developed was really spearheaded towards helping out or penetrating this market a bit. Okay, so our clients, as I mentioned, includes a mix of operators and consulting firms and even government type of institutions. Anybody that has to do fast, efficient compliance simulations and generate reports efficiently, we cater for. And there's some big players using our tools. So what is the IXUS suite? The IXUS suite essentially consists of two main components. And my colleague Johan will show that interactively or with his demo a bit later. But just to briefly explain what these two components are. Firstly, we've got our web-based manager called the IXUS Manager. And this is a place where your firm can manage all of your sites and the compliance status of each of these sites. So you can fill in details, you can add your 3D CAD models of the site, you can integrate measurements with each of your sites. We support various measurement modules. And this is also where you kick off the automatic report generation. And we will show that to you a bit later in more detail. Then on a more lower level, to model these 3D sites, these 3D CAD sites, we provide you with the IXUS modeler. So various modelers can connect to this manager. And this is a Windows desktop application that also includes a fast and accurate electromagnetic field calculator called the Field Assessment Calculator, or FAC in short. And this is what we use to calculate these exclusion zones. So you can add various antennas to sites and then simulate the frequency bands and tilt ranges or anything and power levels that you're interested in, and then generate these three-dimensional plumes, and that is done by our field calculator. And you will also see how easy it is to generate report pictures and also particular field points. So if there's a field point of interest that you want to sample, or alternatively environmental ortho slice. And very important to note that this environment is a three-dimensional environment that you can draw these buildings in. And it does not require extensive CAD knowledge. We've tried to make things as easy as possible, and Johan will show you how that works. So the IXUS suite is a very simple workflow philosophy. It's basically three steps. Step one is you gather your info. And this includes as-built plans, photos, data, anything that you need for that is associated with your site. And you upload these to the IXUS Manager. You can also incorporate measurement data, and at the moment we support tools such as the NADA SRM via this measurement module, so you can incorporate those measurement points here as well. Step two is you then associate with each of the sites that you want to assess a three-dimensional model, and this model is pulled into the IXUS modeler on the user's Windows desktop, and there you can draw the geometries, place the antennas, and then calculate these exclusion zones. And you then create your report pictures and also your field points. And these results are then saved back in step three, saved back to the manager, whereby with a few clicks of a button, you can generate your reports efficiently and accurately. And you can also set up various templates. If you have, for example, templates that you need to adhere to, for example, certain operators have requirements, that's very simple. We assist you with the setup of these templates. And that is also something that we'll demo a bit later. There is a third component, a supplementary component to our IXUS suite, which is called the IXUS portal. It's also a web-based application. You log in here, and if you have, you log in here, and on our IXUS portal, you will find online support, extensive knowledge base of articles that you can use to direct you along certain paths if you struggle with things. We have a service whereby you can request antennas or log feature requests or bugs or anything like that via this help desk ticketing system. But this is just support functionality that we've added to make sure that our users of IXUS gets the support that they need as quickly as possible. On the portal, one of the most attractive features is also our antenna database. So we have modeled to date over 4,000 different antenna models from almost all of the manufacturers you can think of, or manufacturers you can't even think of, right? And even custom type of antennas. We have really spent a lot of time getting various models into our portal. And this list is being expanded almost daily by our antenna engineers. So something that is very nice is if you log in here and you have a particular model in mind that you want to use, you can use the search functionality. The model is listed, its specifications, you download it, import it into your manager, and you can use it very easily. If it's not here, you can request it, and then you will go over to our antenna modeling and synthesis process. So this is where our team of excellent antenna engineers kicks in and takes the information that you supply us, and this is in the form of verified data sheets, pattern files, or other verified sources, and from that set of data, synthesize an IXUS antenna model for you that you can use to generate your exclusion zones. Now, the way in which the IXUS antenna model works varies depending on the type of antenna that we're trying to model. If, for example, we're modeling panel or omnidirectional antennas, well, there's very set methods documented in standards such as the IEC 6232 standard, whereby we can apply ray tracing techniques to generate or to calculate the power spectral densities required for the standards. And essentially what we do is we synthesize a pattern for each of these elemental rays or elements from which rays are emitted using a horizontal and vertical pattern. And what we do is we try to match the manufacturer pattern that's applied with one that we model, we synthesize. So here is an example of our horizontal pattern, which is the dashed line, and a vertical pattern, which is the solid line, the green being manufacturer and black being what IXUS generates. So we match it very, very accurately. We have a different set of engineers that verifies that the matching is adequate. Like, for example, the side lobe here is sufficiently modeled. These side lobes here are very, very small, negligible. The main beam is very well matched. And this will cause, if we look at theoretical versus calculated power density as a function of distance in the main beam, this is just one check. This is not the only check we do. It matches very accurately. So this is just part of our verification process. If you can't apply ray tracing to the particular antenna model, then we need to do something else. And this is now, for example, Yagi-Uda arrays, folded dipoles, patch arrays, lens antennas, or anything that we feel requires a bit of custom attention. Then what we do is we make use of a full wave electromagnetic solver, FECO, which I don't know, I think some of you guys might be acquainted with it. This is a computational EM solver that is based on a technique called the method of moments to calculate fields and pretty accurately around structures. So what we do then is we calculate a near field block around our antenna, and in that near field block, we use that near field block in our IXUS antenna model and our calculator to obtain the power spectral density close to the antenna using trilinear interpolation. So that's what we do in the near field of the antenna. In the far field, we apply the simulated far field patterns to get the power spectral power density. So using this approach, we can essentially model any type of antenna. Okay, now something that is becoming more and more evident is that we require accurate, or everybody requires accurate 5G antenna modeling. And the reason is that 5G and millimeter wave technology makes use of multi-beam or active antennas to essentially to serve this increasing user base that requires these massive amounts of data being streamed all over the place. So these beams are formed dynamically, and they can be steered into various arbitrary directions. It's essentially where the users are located. So you don't know beforehand, like for example, there's no fixed set of tilts. You need to account for this dynamic nature very, very accurately. And these beams can also transmit at varying power levels. So the exclusion zones are somewhat more intricate than traditional 4G models. So what do you do in this circumstance? So what we've been doing in IXUS to a large degree of success is we use the traffic envelope data that is supplied by the manufacturers, as well as maximum gain information that is associated with traffic or service beams, to calculate this envelope exclusion zone around this millimeter wave antenna. And this accounts for all possibilities of this beam steering. In certain cases, if you know, for example, that the 5G radio is configured with a particular beam set in mind, and you have that data available, then we can also model the pattern using that configuration for you. So this is also something that was used by one of our clients recently, or verified by our clients, Bouygues Telecom in France, as I said, where they wanted to calculate the exposure associated with the 5G antenna on a rooftop in France, and so they used our envelope traffic pattern worst case analysis to generate this 3D shape. And we are in the process of correlating the measurement results that they have with our modeling approach as well. Okay, so for current users, and but also useful for people that's not used FECO at all, IXUS at all, what can you guys look forward to in the next few weeks? We've expanded IXUS quite aggressively, if I may put it that way. We will allow for the importing of, in addition to parasolid geometries, also other CAD type geometries such as DXF files, so that you can very easily generate intricate shapes. We've improved the dimensioning of objects. I'll show you a picture now. If I can jump ahead a little bit, these plumes can more efficiently be generated using 3D graphs. We've sped up our lobe imprint calculation. So these, if you have a 3-dimensional exclusion zone here, you can actually imprint that lobe onto a surface at a predefined height. My colleague will tell you more about that a bit later in the demo. And that process is quite computationally intensive, but in this release, we've significantly enhanced that computational speed using an updated algorithm. We've allowed IXUS Manager users to easily add frequency band aliases. Like, for example, if you want to map LTE 1800 to 1800 megahertz, but in another country it's named something completely different alias, then you can manage that in your IXUS Manager. We've integrated auto-saving in the modeler, and we will also be introducing a floating license scheme more, let's say, robustly, to allow our users to easily use IXUS concurrently. Spatial averaging is also a feature we're bringing out, and that is something that deserves a bit of, well, a bit more discussion. So spatial averaging is something that is recommended in international standards such as the FCC, IEEE, IEC, and we're seeing it being emphasized a bit more in updated standards such as ICNIP 2020 and the new ARPANSA standard and so on. And we definitely want to stay ahead of the curve and make sure that our users are supplied with that functionality in IXUS to make sure that their safety analysis is completely in line with what is required by these updated standards. So we've introduced spatial averaging in, let's say, 2 flavors. So the first flavor is what we call a moving average type of scheme. So if you when we calculate this three-dimensional exclusion zone area, we calculate the electric field at individual points. Now, with our spatially averaged 3-point scheme, we calculate the field at a particular point, but in addition to that evaluation point, we also calculate the field at a distance of 0.2 meters above and 0.4 meters below it, and essentially models the 3-point whole body average. And this was taken out of the ISC 6232 standard. I know there's a lot more, and I'll show you now how we cater for generic type of sampling. But this is the one that is applied to this 3D lobe environment. For a single point type of averaging, you can do a bit more. You can specify the start height, there P1, and the range. Here's the range is 2 meters, any point in space. And over that range, you can then also specify the vertical spacing that you want to apply between these ranges, and then you will get the number of vertical samples that will be used for our spatial averaging. So here, for example, you get about 20 samples if you take it from 0 to 2. This is something that is recommended by the ISC standard, the FCC standard. So this is now taking the average incremental points along this line. Computationally, it's not very expensive because we only have to calculate the field points there. We've also spent some time on enhancing our environmental orthoslice functionalities. We've added 2 flavors to this. So the historic one that we had that a lot of the current clients will be familiar with is a continuous type of environmental slice, whereby the field values or the percentage of standard or the results, right, is reported on a smooth scale here from 0 to 100, from blue to red. So you have this continuous type of environmental slice. But we've also updated this now to support a discrete type of slice where you can specify the ranges and associate the ranges of that you want to see, or let's call it buckets. And each of these ranges or buckets are then associated with a particular color. So you get a more discrete type of environmental slice result over here. This might look familiar to some of the American-based participants that's on this webinar. Before I go off, we also updated our units that you can use in IXUS. So to specify geometry, dimensions, or what the units that measurement tools report or 3-dimensional grids report, you can set it between metric and imperial, so meter, feet, inches, and so on. All of that is supported in here. Okay, that was a very quick rundown of IXUS. Before I give over to Johan, I just want to emphasize these slides. I can circulate these slides to everybody afterwards, and well, perhaps in the video format. But you can always visit our website at ixusapp.com. You can email us, info@ixusapp.com. We've got a YouTube channel over here, listed over here. This the reference that you can view these videos that we make, and but you need to test drive it. I think that's a very critical thing. So we are offering anybody a free 30-day trial, fully featured, cloud hosted. We sort out the IXUS manager hosting for you, and you can connect your IXUS modelers. And in addition, we'll throw in 1 free antenna request if it's not on our list already, but the chances are very slim. So and if none of that appeals to you, please, you can come and enjoy a barista quality coffee at our address here in Stellenbosch, South Africa. Obviously, applying social distancing, of course. So bring your mask. Thank you. I appreciate everybody taking time out of their day to listen to us. So at this point, I wonder what's more efficient. Is it more efficient to hand over to Johan? I think so that everybody can see, and then we take some questions.
Yeah, if there's any questions, you can ask us now. But I'll quickly share my screen as well.
Okay.
Okay, can you guys see the login page?
Yes.
Okay, great. So For the demo, I'll just run through one very basic site from scratch to where the report is done. So I would like to show you just on a very basic base station how to resolve your compliance issues. So when you log in, there's an opportunity to download the IXUS modeler. So I've already done that. So I can just go click on OK. So when you log into the IXUS manager, this is where you manage all of your base stations. There's usually a long list of base stations here. For this example, I'm just going to focus on this one site. So I'll click on this site. That's my site name and everything. Just want to check this chat quickly. Sorry. Okay, Jim, I'll answer your question in a few seconds. All right. So I just want to explain to you what this manager part does quickly, and then we'll go over to the modeler. So for each base station that you are assessing, you can fill in all of the site details. You can also bulk upload this with a CSV file if you want to do that. You can fill in basic things like the address, the lat long, who the site owner is, who the carriers are on site. And then there's some general fields here as well that you can use for project management. And then there's a space for where you can fill in your signage comments, access control comments, or whatever other comments is required that will go into the report later. So this is all saved here. So I've added some example comments there. Just running through all of these tabs quickly. If you go to the measurement tab, in this case there is nothing. But if you had done measurements on this base station, then you would see each of the measurements done and the values that you got at each of your measurement points. Okay, and then field points is points of interest that you can find in the CAD model. So there's one example here already, but we're going to add some more. If you go to antennas, then there's only one example that I added for now, but this is where you add the list of antennas that are associated with this base station. And then I'll just go to the photos and documents quickly. So in order to sufficiently run this business of compliance, it helps a lot if you keep all of your site documents for your base station together. So you can use this similar to Dropbox. You can save any amount of data here. So all of the site photos, or this is just now an example site that I've added some photos of, or as-built documents, or whatever you need to save. And then on the next tab is the reports that will generate. Already generated one there, but we're going to make another one. So this is now the site that I'm going to open in the modeler. So when I click on 3D model and pictures, there is usually a history of who worked on the model over the years. So you can see who last worked on it. You can change some calculation settings per each site. And then there's also a link where you can download the modeler. So in this case, I'm just, to save time, I already created the building that I want to use for the example. Just want to make sure. All right. Okay, so what I did now is I just opened the space station. So directly from this website, I went to start download, and then it downloads a little shortcut, and then it opens the site in my modeler over here. So it's just downloading at the moment, and this is a cloud hosted version of the manager, so you can access it from anywhere. Okay, so I already drew a building here. and I don't want to waste time on doing drawings, but just to show you how easy it is, I'm going to hide this for 1 second, and I'll show what the blueprint looks like. So I added a picture from Google Earth. Let me just hide this antenna as well. So say, for instance, you don't have drawings of your building, or you might have as-built drawings that are in PDF form or hand-drawn or whatever. Just as an example to show you how easy it is to draw something here. Say, for instance, I want to draw a block. So I can click on the block, and then it's very easy to just select this shape and size. And then if you don't want to have it here, then you can just delete it. Just to show you how easy it is to draw a building, I'm going to just go around the outlines of this building. Oh, I'm doing it very wrong now. Okay, just for the example, it doesn't matter. Just to get the idea, you can easily follow the edges of a building, not like I did now there. And then you go extrude, choose a height, and then you've got something to start with, and then you can start drawing things on top of that. So that's basically how you would do something like this. In this case, I'll show all again. So what I did is I imported a DXF file of the building that came from the as-built. So it was very easy. So I just imported the DXF file and extruded that to give you this building, my example building. So what we're going to do here is I'll add some antenna models to this building, and then we'll make a report for it. For an example, I already added this one antenna. In IXUS, if you want to see the properties of anything, then you can just double click on it. So double click on this antenna and it gives you the properties. So now you can see, if you go to details, you can see this is a ComScope FFV for 65C R6. And for this example, I added N41 and AWS band. Just as an example, and all of the available tilts for this frequency for this antenna is in the list here. So you can choose what the tilts are. You can also choose a tilt range that will range from, say, for instance, from 12 to 3 or whatever. So then you can fill in all of the power levels per port, and there's also a field where you can fill in the feed system loss. So if you want to cater for cable losses. All right, so this is just one example antenna. For our assessment, just to give you an idea of the size of this, we've got a little man that we can make this guy 2 meters. Sorry, I'm not going to work in feet. I get very confused if I do that. So on this building, you can see that this antenna is rather low, and it will probably cause a problem. Just to give you an idea of the size. So to generate the plumes, I'm going to add another antenna, and I'm too lazy to type in everything again, so I'll just copy it, and then I'll place it on the other corner here and change the azimuth to something pointing away from there. So now I've got 2 antennas on my site. And then after I did that, then I can just go click on simulate, and then you can choose the standard from there. So I'll leave it on FCC for now, and you can choose a detail setting as well. Doesn't make much of a difference, but that's usually quite fast to calculate, unless you've got like hundreds of antennas. Most of the time, it takes a few seconds to run this. So while we're waiting for that, I'm reading here from Jim. Can use ground height imports of some sort. Multiple broadcast towers. Not sure what you mean exactly, but what you can do is you can import antennas at specific heights. So we can run a script to do that. And the frequency range is Donnie can answer that maybe as
Yes,
well, but
we
I
go
think it's
very low to about 30. We've modeled 30 megahertz low power type of dipole and omni antennas. That's the lowest, well, on the lower end, and on the higher end, we've modeled 30 gigahertz dish type of antennas. So we cover quite a large frequency range.
okay, great. So now just to cut to the chase here for generating the report. If you look at this shape, so it's very useful to see now where someone will go into this area. It will be non-compliant. So the yellow is 100% occupational, sorry, 100% public, and the red is 100% occupational. So in order to get your mitigation rules and regulations that you need to follow to follow it more easily, it's better to look at where the accessible areas are. So what I'll do is I'll run this simulation, the create lobe imprint. So I'm going to leave it on 2 meter. That's just above 6 foot. And then so what this does is it checks down if any geometry is below this shape within 2 meters. In other words, it will give you exactly the area where a 2 meter tall person. So if I take my little, what's this guy's name? 2 meter Peter. If this guy walks around here, once he goes over that line, he will be overexposed on his head. This, of course, is point calculations, and I'll switched over to spatial averaging just now. I just want to show you how easy it is to cater for where signage needs to be installed and so on. So let's just assume that there's no chance of moving the antenna, or let's make it for this example. Let's have a look if this is compliant if we move this antenna up a little bit. So I moved it. Did I move it? No, I didn't move it. Move. Oh, sorry, I just need to unlock it quickly. So I go move, and so I want this. So I'm changing it to like a pole mount on the parapet wall, and then we have to run the simulation again. So let's do it on fast. Say, for instance, you were on site and you realized that there's a big problem, and you asked them to raise the antenna. So now we can do the lobe imprint again. You see, it's very difficult to see where the accessible areas are. You can also use a point below the zone height measurement like this to indicate what the height is. But if I run the lobe imprints now again, then we should see that this problem is now not there anymore, and we can ignore that completely. So we just need to worry about signage in this area. So for our mitigations, I'm going to add a railing over here, saying this railing must be all the way through so that no one can have access to this area. And I'll add another one on the other side. That doesn't really matter. Just put it to there. That's good enough. Okay, and then we're probably going to need some signage. So we're going to need a caution sign, if I'm not mistaken. So let's put a little caution sign on this pole over here. Just place it like that. There's one, and we're probably going to need another one over here. So I'll just, to make it easier, I'll just place it on the wall there. Okay, that's good enough for the example. Now we've resolved our problem in this area, and now we can start creating pictures for our report. To do that is very easy. On the right-hand side, it says default view. If you click on the little picture, then it creates an instance of what we're doing here. So it's the same model, but if you move something in this move something around in this model, like for instance, if I want to make a top view, I can change the name to top view. Then I can still go back to the default view, and it still looks the same. So it's sort of a live picture that you can create. And once we're done at the end of this assessment, then this will go directly into our report. So for this example, for this top view, I'm going to add my signage as well. And maybe, yeah, so that you can hide this as well if you want. And then just a little bit closer to home for FCC rules, you're going to need something more like so you're going to need an environmental slice. So let's place one like this quickly over here. I just want to make a quick example, and I want to see let's look at the e-fuel total for this example. So I made one over here. So the maximum, if you look at the exclusion zone, it's pointing this way, so the maximum is over there. That's one way of indicating the zones. Another way is I created another environmental slice all the way around here. So I just want to hide this part, change the transparency a bit. So for those buckets and colors that are required by FCC rules, we added this discrete. It's a different way of showing the same data. So this is very similar to what the other tools in the US use at the moment. It's just our implementation of that. But you can still make reports that show you the same things that you're used to. So I'll just call this top view again. And this, I think this is public. This is, yeah, public. Okay, so there's a little legend that shows you. So it's pretty easy to draw, to indicate in any of these zones. Another quick thing that I need to show you before we generate the report, or I think I'll first answer some questions before I close it, but there's one thing I still want to show you is if you have a point of interest. So for instance, you want to know what the value is over here. Okay, so I want to know what the maximum is from 0 to 2 meters. So then it gives me a maximum value of 68.48%. But if I want the average, like Donnie showed in his slides as well, now I can choose. I want to do a measurement point every 0.1 meters, or I can make it like 0.2 or whatever, and then it will take 11 samples to give me an average of this area. So then when someone would stand there, this person, the average for this person will be that. Just one thing that I have to change quickly. So that I think this, if I remember correctly, these calculations were done with points, single points, and not spatially averaged. So if I go to preferences, then I can change this to the 3-point scheme. And then if I run the simulation again, then the exclusion zones will be slightly different for the spatially averaged simulations. And it will also change in my pictures. Okay, so you see it's slightly different. And if I go to my views here, luckily my mitigations are still valid. Let me just hide that part quickly. And over here you can see it looks slightly different. All right, so this is in a nutshell how you can use it. There's lots of other features that I don't have time to show now. Before I generate the report, I'm giving you guys a chance to ask questions. I see there is some questions when you specify in percentage. Sorry, Tim, what is the question? When you specify in percentage, what is that percent of MPE level?
It's percentage of the standard.
Yeah.
Yeah. We specify percentage of the standard. If it has occupational set, then it's percentage of the occupational standard. Or if it's the public standard, public limit, then it's percentage of the public limit, as detailed in the particular standard that you select. Yes.
Okay. Yeah. 3-point spatial.
It's vertical.
Vertical. It's for this scenario, it's almost impossible to do horizontal, and in fact, no, that's not very realistic to do.
We opted for vertical because when you start including horizontal averaging as well, you need to take into account the orientation of the plane. All right, so to what, where do you orientate the plane towards the broadcaster with the highest transmission rate, or to avoid that confusion, to make things accurate and understandable and still adhere to the standards, we decided on a vertical only sampling scheme for now. But we are always updating IXUS, so the more we learn from the market, we'll introduce more of these averaging schemes.
If you would have had one antenna here pointing in one direction, then for your measurement area, you could have implemented something that has taken horizontal into account as well. But since we're catering for a complete environment in any direction, we would have calculated a cylindrical calculations for each point, which will make it a lot more computational. It will be a lot more difficult to calculate that. But for now, the vertical is what is recommended by all the standards, yeah. So we're implementing in everything that is required. Okay, so now after I calculated everything and I'm happy with this, I might add some comments. So you can easily type something here that says, okay, whatever, not accessible. Okay, and then so now I'm happy with my pictures, and then I'll go ahead and save back this base station to the manager. So if I click here, save back to the manager, then I have to type a comment. And then I click save, and then it captures my pictures, and then it encodes the file and uploads it to the cloud. So once this is done, then I can go have a look what my pictures look like in the manager, and then generate the report. Yeah, just wait for it to upload quickly. Right, so now I can close this part. If I go back to the manager now, then you'll see these are the pictures that I created. And I can have a look at them here. And I'm just going to leave them like that. And now we'll go and create the report. So the report is really easy to do. There are, in this version, there's a few example reports uploaded. I uploaded 1 year earlier. I hope it works well. Signage comments. Now you can say one caution at area A, or whatever you want to type there, and then access control comments you can change as well. And then you can have a look at what your pictures are going to look like when they go into the report. You can choose to remove or rearrange them. And since this so there would have been another step where you could add your pictures, but in this example, I don't think there are any pictures. But the report is essentially created now with the data that I entered. And the report is just in Word document format. So now you can see the site is owned by ABC Properties. You can see the site name, number, name, all of these things. And then all of the boilerplate stuff is already added to my report. And if I scroll down, then I'll see my pictures already here. So I don't have to do anything else. And my legend is already added. My signage and access control comments are already added. And here's a list of all of the equipment that are on site. So I don't have to do anything. It's already created. There would have been site pictures, but I removed that part just now. And then usually there would be your engineering signature that is uploaded to the system. I haven't uploaded anything for now, but it would have been there. And just to show you how easy it is to create this report, I'll quickly show you how to change something. So say, for instance, I want to change this site number. So you can take any docx file and then go to design mode. And then it will give you the content controls. If you go properties, if you go to the properties of the content control, it gives you the site number. And this is what we use to generate the templates. So it makes it very easy. Anyone can change the template. You can have hundreds of templates. So for every type of file or type of site assessment that you need to do, you can have your own template. Okay, so this is what we use to create the template. At this point, usually there's one or two things that you would tweak in the file, and then you would export to PDF. Okay, so I'll just save here. And now I can go ahead and change my site to site assessed and give it to someone else to approve. All right, so that's my whole story. Thank you for listening, and there's still a few minutes left for questions if you guys have questions. Yeah, so if anyone has questions, go ahead, please go ahead. Otherwise, thanks for joining.
Please remember about our free trial. If you need that set up, please contact us and we'll get that going.
Okay, well, thank you very much.
What type of coffee? Oh, we have, today I checked in the kitchen, we have Colombia beans. So, but if you travel all the way here, any type of coffee you want, Tim.
Okay, thank you very much for joining, everyone. And we'll hope to hear from you soon.
Okay. Thanks, everyone. We will do that. We will share this demo via YouTube link with everybody.